And we're at video CA6. This one is going to cover Chapter 1, Section 3B in the textbook, and I will drop a link to that online textbook in the description below. I broke this section up into 3 parts because it had a lot of information in it and I didn't want you to get totally overwhelmed. So this one is going to be short and sweet. We are going to learn rationalizing denominators. Now, I'm sure you've all done this at some point before. Do you have to do it? It depends on your directions. When I was in school a billion years ago, you had to rationalize your denominator. It was like a cardinal sin if you did not rationalize that denominator. But now, with calculators being so prevalent, not everybody insists on it. And I tell you that because I want you to be aware of your directions. If the directions say rationalize all denominators, then this is a skill you're going to need. Otherwise, it's kind of up to you. So what's a denominator? It's the bottom part of a fraction. Well, if you need to rationalize it, that must mean that it's irrational, right? We go back to the very first video, number sets. What are irrational numbers? Well, there's pi. So if you've got pi in a denominator, you got to do something about it. The other thing was, what about when you have square roots or roots of imperfect roots? Now we're dealing with square roots. So if I have square root of 3, that's an irrational denominator. So let's just say, if I've got 2 over square root of 3, to rationalize it means to make it not a square root anymore. So what can you do to this number to make it not a square root? Well, what if you multiplied it times itself? What is square root of 3 times square root of 3? Well, that's square root of 9, which is 3. So anytime you multiply a radical times itself, you just get rid of the radical sign. You just, undo the radical. But you can't just willy-nilly start multiplying radicals everywhere. You have to have a mathematical rule that balances that out. Well, you can do anything you want to a fraction, multiplication-wise. You can multiply any part of a fraction as long as you do it to the top and the bottom. Since I multiplied the bottom by square root of 3, to balance it out, I'll multiply the top by square root of 3. Because what is any number over itself? It's 1. What is multiplication by 1? That's that identity number. So you haven't changed the value, we're just changing the looks. And when I multiply across the top, now I have this. This is good because the denominator is rational. And that, like I'm saying, that goes back to when everybody didn't have calculators and it was easier to get a mental picture of something over 3 than it was something over square root of 3. So, let's look at another example. Here's example 8 on page 51. We have 2 square root of 3 over 3 square root of 10. Now, what do I need to rationalize? This denominator. You only want to rationalize the radical part. So what you're going to do here is you're going to multiply by just the radical portion. Square root of 10 over square root of 10. So let's look at the math here. Everything that's outside the radicals gets multiplied together. Plus actually has a 1. So we're going to have 2. And square root of 3 times square root of 10 gives you square root of 30 under here. Now let's do the denominator. I've got 3 times, what is square root of 10 times square root of 10? The radicals multiply together, so I've got square root of 100, which is 10. And then if I want to simplify this, well, I do want to simplify it. That gives me 30. Now, check for more simplification. 2 and 30 as a fraction will reduce down to 1 over 15. You don't need the 1 in your numerator. So now I have square root of 30 over 15. Am I through? Well, you have to check that radical. Is there a perfect square that will go into 30? No, there is not. So yes, this is your final answer. We do get a little bit deeper with this. Now we're going to need to talk about a word, conjugate. What is a conjugate? A conjugate is a binomial with the opposite sign of the given binomial. I know that's confusing, so let's look at an example. The word conjugate is based on something else. I can't just walk up and say, hey, what's the conjugate? You have to have something to have a conjugate of. So if I have 2 plus a, and I want to write the conjugate, its conjugate is going to be the same numbers with a different sign. That's all it is. If I've got 3 plus square root of 2, the conjugate of that is 3 minus square root of 2. If I've got x minus square root of 7, the conjugate of that is x plus square root of 7. So now that we know what a conjugate is, let's look at what happens. So let's take 2 plus square root of 3, and I'm going to multiply it by its conjugate. 2 plus square root of 3 times 2 minus square root of 3. Now how do you multiply two binomials together? There's your good old FOIL method. So I'm going to multiply the first. 2 times 2 is 4. My outside is going to give me negative 2 square root of 3. My inside is going to give me positive 2 square root of 3. And then my last two. I've got a positive times a negative. So I get a negative. Square root of 3 times square root of 3 is just 3. Now look what happens to these inner terms. You've got minus 2 square root of 3 and plus 2 square root of 3. They cancel each other out. So what I have is 4 minus 3, which is 1. So do you see what happened there? I got rid of my radical, which is what we were just talking about. Rationalizing denominators is getting rid of the radical in the denominator. Now where does all this tie in? In that first example, you had a radical in your denominator, and it was just a single term, so that was really simple. I told you to just multiply that times itself, and you got 3 square root of 2 over 2. That was simple. But let's look at what happens if you have a fraction that has a binomial in your denominator. Let's try this example. This is the try it example number 9 on page 52. So I do need to, I'm told to rationalize my denominator. So I'm going to multiply by the conjugate of this, which is 2 minus square root of 3 on the top and on the bottom. And when I multiply the top, I'm going to distribute. So 7 times 2 is 14 minus 7 square root of 3. Down here on the bottom, I'm going to use the FOIL method. So 2 times 2 is 4. And then 2 times negative square root of 3 gives me negative 2 square root of 3. Square root of 3 times 2 gives me positive 2 square root of 3. And then my last two, negative times positive gives me negative. Square root of 3 times square root of 3 is square root of 9, which is 3. So let's clean this up. These two, the 2 square root of 3, I've got one negative, one positive. That makes 0. So now what I have left in my denominator is 4 minus 3. All right, up here on the top, this doesn't change. I can't combine these. What's 4 minus 3? 1. So I have 14 minus 7 square root of 3. And you could, if you wanted to simplify this just a little bit more, you could say, well, that's got a greatest common factor of 7. So you could divide that out and get 2 minus square root of 3. Some books would have it either way. That's kind of up for debate. And that is all there is to rationalizing a denominator. So that was a short and sweet video, and I've got one more video for this chapter, or for this section, and then we'll be done. We can move on to section 1.4.